Our goal today, as we look at section 10.1 of our conics unit, is going to be just to classify conics based on an equation. But first we need to understand what a conic is. If you imagine taking a cone-shaped object and slicing this cone-shaped object in different manners, you will see the shapes of the conic. If we take the cone-shaped item and we slice straight down through it, we'll end up having a parabola as a cross-section of this conic, somewhat like that. If we turn the conic directly on its bottom or on its tip, then the bottom side of the conic is a circle. And so we have a number of different conics that we have that we can get based on what we slice it, and if we have two conics based on each other, or if we were to slice this conic on the diagonal, something like this, and take that cross-section would be called an ellipse. So if we stretch it straight up and down, that's a hyperbola. Parallel with the edge of the conic, that's a parabola, and then the bottom side is a circle, or straight on the diagonal through the middle is an ellipse. So let's just label these four conics that we have down below here. Here we have the basic parabola. You're all very familiar with what a parabola is. A normal parabola, is up and down, but we're also going to consider parabolas that are sideways. A normal parabola is y equals something x squared. A sideways parabola is x equals something y squared. So just two different styles of parabola. Obviously, on the second version, we have a circle. The standard circle that you did back in Algebra 1 and geometry had formulas like this: x minus h squared plus y minus k squared equals r squared, where r is the distance from the center point out to the edge. So that's just kind of some familiar shapes that you've done in the past. Down here at the bottom we have two new shapes. This is an ellipse. An ellipse is defined as all the points that are equidistant sum from two other points called the focus points. And what that means is, if you have these two focus points and you were to draw the line to any edge, the sum of the red lines is equal to the sum of the magenta lines, which is equal to the sum of the green lines, which is equal to the sum of the black lines. And so all of these sums of lines are equal, and that's the definition of an ellipse. And so an ellipse is just a very simple subject there as we're working through that. We're going to talk about a standard form of an equation of ellipse in a little bit. And then our last one over here, this is called a hyperbola. It also has focus points, but the hyperbola characteristics are a little bit different in terms of the difference of the distances is a constant versus the ellipse has the sum of the distances is a constant. And when I say the distance, I just kind of mean that minus that. So let's kind of look at some equations, and that's our main focus today, is to classify equations of a parabola, a circle, ellipse, or hyperbola using just some graphing. So what we're going to do to graph these on our calculators is we're going to have to consider the fact we have y squared. So what I'm going to do is take this equation and I'm going to solve this equation for y. So I'm going to make it really easy. You realize they have a y squared, and so we're going to have the square root of something. We have that 4 on the other side. I'm going to bring over the 1. I'm going to bring over the 3x. I'm going to bring over the x squared. And then I have to take the square root of that, so I need to consider plus or minus the values of that. So what I like to do is I like to bring up my calculator, and I've graphed and plotted in these points here to our first equation, and we have 4 minus x squared minus 3x plus 1 as our problem. And you see I have the values of my function either as the positive value, or down on the second one I've actually accessed that to be the opposite. So I did the opposite symbol, and then I did alpha trace, and I accessed the y1 function, which then allows me not to have to retype all this y1 equation. So let's take a look what this is going to look like. I'm going to go zoom 4, which is a smaller figure. And so here we have the top part of the circle, and the red part is the bottom part of the circle. And so I think I just kind of gave things away here. But what is this shape? This shape is very simply a circle. Now let's take a look at our second equation. We need to solve this second equation for y. So we're going to have the 4 plus the 1 minus the 3x minus the 2x squared. We're going to divide all that by 5, and we're going to take the square root, realizing we have plus or minus, and that's going to be y equals. So let's plug that into our equation. And once again, I've done these in advance. So we're going to go back to our y equals. I'm going to delete this one by making the equal signs white. I'm going to go down to my second equation. Here's my second equation already put in. And now here I put the opposite of y3, because now I want to take the opposite of our third equation here. So let's take a look at what this looks like as a graph. It's not quite a circle. That's our other shape, and that is called an ellipse. So our second equation is the shape of an ellipse. Let's look at our third equation and solve that one. We're going to have y equals, and by now you realize you've got the 4 plus the 1 minus the x squared, and we're going to divide all this by -2. We're taking the square root of that with a positive and a negative, because 2 square roots equals 2 answers. Let's go to our equations. Y equals so we're back again. So as we look at these two, we're going to have to go them down, and we're going to have to deactivate y3, deactivate y4, and we're going to have to activate our next two equations. And you notice once again I've put the opposite of y5 in, and here we have it dividing by -2. Realize that's the opposite sign and not a minus sign. Let's take a look at what this graph looks like. Something new. So it kind of looks like two parabolas, but that's actually the shape of a hyperbola. So the positive is the green on the top, the negative is the orange on the bottom. So that's the graph of a hyperbola. So here we have, let's fill that in now. This is a hyperbola. Okay, let's take a look and solve our next one. Y equals, we have the 4 plus the 1 minus 3x, and we're dividing by 2. We're taking the square root of that with a plus or minus. So let's go back to our graph. 4 plus 1 minus 3x. So we come down to our fifth graph. We're going to deactivate that fifth graph, deactivate the sixth graph, the negative, and we're going to activate our next graph, 4 plus 1 minus 3x divided by 2, and activate the opposite of that graph, which is now y7. Let's take a look at this graph. There we go. Looks like that's a sideways parabola. Okay, so here we have a parabola. And I want you to notice that the y squared there is what causes it to be sideways. All right, let's look at our last one and solve our last one for y. Y equals, we got the 4 plus the 1 minus the 3x squared, all divided by 2, but we don't have to take the square root, so this is just going to be, I would guess, a very simple one to graph. Let's take a look at what this looks like when we graph it. We're going to go down all the way to the bottom. We're going to activate equation 9. I'm going to go up, deactivate equations 8 and 7, and we're going to graph this. That's an upside down parabola. Probably not very surprising to you, since you saw that one of them was squared and the other one was not. So here we have another parabola as a possibility. So Our goal today is to be able to classify these conics without graphing, without going to our calculators and solving them for y and all these kind of situations. So what I want to do is give you some clues, some hints as to how to identify these without graphing. So let's come down here and let's look at some basic rules. Our first thing we're going to consider is the number of squared terms. Okay, so I'm just going to put a little side note up here, and I'm going to say the number of squared terms. Okay, a parabola has one squared term. Very simply, if the x squared term, if the x is squared, it's up and down, like so. If the y is squared, it's going to be sideways, positive to the right, negative to the left. So let's go back up here and let's notice equations 4 and 5. Only one of them was squared in each of those cases. Now let's look at our other part, squared terms. Number 1, number 2, and number 3 each has both x squared and y squared. So by default, we can say a circle is going to have 2 squared terms, as is an ellipse, as is a hyperbola. Now we look at the second part of our problem. The second thing we're going to focus on is going to be the coefficients. And so we now want to look and examine the coefficients. Remember, coefficients are the numbers in front of the x squared and the y squared. So we're going to look at the coefficients of x squared and y squared. All right, for a circle, the coefficients are going to be the same. So let's come back up here to the top, and I want you to notice the one for the circle. The coefficients was 1 and 1. Those are the same. Now let's look at 2 and 3. On 2, the coefficients are 2 and 5, and on 3, the coefficients are 1 and negative 2. Maybe you see a pattern there, but for an ellipse, the coefficients are going to have the same sign, either both positive or both negative. Okay? And a hyperbola is going to have a different sign. One's going to be positive and one's going to be negative. So as you looked up here, you see your hyperbola, you have a positive x squared and a negative 2y squared, versus a ellipse, you had a positive and a positive. So that's kind of a summary of how you can just look at an equation and determine what the signs are. Now our homework tonight is just going to be identifying what equations are. I have 7 equations on a worksheet for you, and I just want you to tell me what these are based on analyzing them and understanding these rules for classifying conics.